And then starting from module 2, we are going to slowly relax our assumptions, right? So first of all, we are going to relax the assumptions about viscosity. The assumption of a fluid that is not viscous is actually not true, right? We all know that's not true. Every fluid, I mean, has viscosity. So what we are really assuming when we look at inviscid fluid is that we're assuming the viscosity only happens within a very thin layer near the boundary. We all know that's called a boundary layer, right? I mean, you have all taken unified fluids. And we are also assuming the boundary layer is extremely thin. It's so thin that it does not affect any of the fluids outside the boundary layer. That is what we are assuming. But even then, we're going to be missing a bunch of effects. We're going to explain the lift and the pressure distribution about an airfoil pretty well using viscous aerodynamics. But we are not going to be capturing how much drag we have on the airplane. Right? We are completely missing the viscous effects inside the boundary layer, which is pretty much what's going to give you the drag on an airfoil. So going into viscous aerodynamics, we are going to be looking into what's happening within this thin boundary layer to start to explain the drag on an airfoil. We are also going to start looking at effects that is not going to be captured even on the lift distribution just by looking at viscous aerodynamics. That is, when you approach a certain angle of attack, if you look at, for example, look at angle of attack versus moments and the lift, you're going to see the airfoil starts to stall at a certain angle of attack. And there is no way to explain that except for looking at viscous effects, looking at what happens to the boundary layer, okay, the separation of the boundary layer. We are also going to explain what's happening here at the trailing edge, right? If you have taken unified fluids, you might know that there is something called a cutter condition, basically saying that the flow at the trailing edge of an airfoil, right, has to satisfy a certain condition. Basically, the velocity cannot be infinite. And the viscous effects is going to explain why that is the case. So basically, we are going to be relaxing assumptions and look at why things are what it seems to be in viscous aerodynamics.